Now we're going to continue on with the atom basics section. Of all the sections in the test, this one I was disappointed in our results. I felt like it wasn't as hard as it just came across. It must have been harder than I thought it was. So nitrogen, oops, lost my connection, there we go. So nitrogen in, it has 7 protons. Here, let's get rid of, I made a couple of squiggles here. Has 7 protons, and this says it has a mass of 15. It has a -3 charge. So then maybe that'll help. Okay, the first question is how many electrons? Well, E equals P unless what? Unless there's a charge. So we know there's 7 protons. Y'all remember that's protons. This number is protons and neutrons. That's the mass number. Okay, this protons is the atomic number. All right, so if we E equals P unless there's a charge. So is there a charge? Yes, there is a charge. So you know the charge is -3. So if it's -3, have you gained gained or lost electrons? Well, since electrons are negative, if you have a negative charge, you've gained electrons. So normally you would have had 7. You've gained 3, so now you have 10. Another way to do that is to use this formula. Protons minus electrons equals charge. So if the charge is -3 and the protons is 7, so 7 minus x equals -3. So how do you solve for x? Well, you subtract 7 from both sides and you get -x equals -10, or x equals 10 if you multiply both sides by -1. Either way, it's 10. Okay, how many protons? We already identified that one. This number here tells you the number of protons. It's the atomic number. There were 7. How many neutrons? Well, protons plus neutrons equals mass. So you know the mass is 15, and you know there are 7 protons. So if you solve for n, it has to be 7 plus something equals 15. Something has to be 8. All right? Anions are negative ions. If they're negative, have they lost or have they gained electrons? So they gained. Okay, what part of the atom is most involved in interactions between atoms? Because they're on the outside. So what's on the outside? Is it the protons, the electrons, or the neutrons? It's the electrons. Protons and neutrons are in the nucleus. So again, nucleus, then the electron clouds all around it. All here, electrons everywhere. If you actually draw what it looks like, there's the 1s, here's the 2s, here's the 2p. It has 3 parts in the 2p, remember? 3s, 3p. But what's in all these s's and p's? It's electrons. Okay. So now the smallest unit of the atom that retains the properties, the smallest unit of an element that retains the properties of that element, that's the atom. Neutrons and electrons and protons, they can be in anything, but one atom will have a distinct identity. Like you can have an atom of copper, or an atom of lead, or an atom of oxygen, but the simplest piece of something is an atom. Okay, now what were the positive things in the nucleus? Protons. All right, electrons are negatively charged. Is that true or false? That's true. But do they have the most mass or the least mass? They have the least mass. That makes this statement false. This part's true, but that part's not true. Neutrons, they have a neutral charge, or 0 charge. Okay, now what causes a charge? Remember ions? Ions are charged. So what causes a charge? Are you going to lose or gain? You lose or gain what? You lose or gain electrons. That's what causes our charge. Protons always stay the same. Now where is the electron cloud again? So go back up here. This is all electron cloud. Is this dense or not dense? Well, since electrons don't have any mass, or at least negligible mass, almost none. The protons and neutrons have all the mass of the atom, almost. Each proton is about 2,000 times more massive than an electron. So electrons have the electron cloud has a very low density. And remember we were talking about an atom as big as Busch Stadium and all the mass would be the size of a tennis ball in the center. So the electron cloud is negative and has a low density. All right, is the nucleus empty space which the electrons occupy? We just said that the nucleus was very dense, didn't we? So the answer is that's false. All right, if it's neutral, does it have a charge? So neutral means that P equals E, because P are positive, electrons are negative, and positives and negatives, when they're equal, create neutrality. So that's not a choice here, so the answer is C. Okay, 84, in this problem, that's the mass number. What makes up the mass? Protons and neutrons. Remember we've said protons plus neutrons equals mass. All right, now what do the electrons do? They move around the nucleus. We don't really know how they move, so really they're in a region of space. So they're in orbitals, and we don't really know how they move inside the orbitals. We know what the orbitals look like. There's an s orbital. Here's a p orbital. Here's a d orbital. It's just one orbital. So we know what they look like because we calculated them using mathematics, but we don't know how they travel in that path, or in that shape, I should say. All right, different isotopes. Now we've got a new term, isotopes. Isotopes have different mass numbers. What causes mass? Protons plus neutrons equals mass. So isotopes mean different neutrons. Same element, but different neutrons. So if the neutrons change, would that change the mass number? Yes, it would. And so that's true. Now, do all atoms of the same element have the same number of, what do they have? What identifies? Was it the neutrons that identified, the protons and neutrons together that identified? Atomic mass is the same as this. It's protons that identify what the element is. So that answer has to be protons. Okay, so if I said, how do you know what subatomic particle determines the identity? It's protons. Remember I told you that they never change. They never change for a particular element. The only way a proton number can change is if a nuclear reaction. Okay, aluminum 28. 28 is the mass. So protons plus neutrons equals mass. Aluminum on the periodic table has an atomic number of 13. So 13 plus N equals 28. So N would have to be 15. So the answer is E. 13 plus 15 equals 28. All right, this one, did they give off light when the electron went, like, if here's your nucleus and here's your first energy level, second energy level, and third energy level, and so on. When the electron goes from here to here, does it give off light, or does it give off light when it comes back down? It gives off light when it comes back down because it loses the energy that it gained. So this answer is false because they give off light when they fall, not when they go away. All right, and this may have been the hardest question for you. You've got 75%. Is that more than half? And then you got 25%. So if I wanted to get the average, is it 21? No, because there's more 20 than there is 22. It'd be like saying if all the girls in a room weighed 100 pounds and all the boys in a room weighed 200 pounds, and suppose you had 20 girls and you had 5 boys. Would the average weight be 150 of all the people in a room? No, because you had to multiply 20 times 100 and then 5 times 200 and divide by 25 because there's 25 people. So in this case, you've got more of the 20 than you do the 22, so the average is going to be closer to 20. In this case, what would the average be closer to? It'd be closer to 100 than it would be to 200 because there's more of the 100. So here it's closer to 20 than it is 22, so the answer's got to be B. All right, that's the end of that little section, so we'll save that one. So I can find my cursor here. Here we go.